All right, now on to 7.4. As you can see from the top of this, there's more formulas, and I'll do the same thing I did as in 7.3. We'll go over in class where these formulas come from so that you can kind of trust them and know them to be true identities. But for right now, I will tell you, a little heads up, these are going to have to be memorized. So the sine, cosine ones, the tangent ones do not. So let's put no memorize. Okay. And with a lot of things we do, the more you work with them, you'll find that they do get stuck in your memories, okay? All right, so for right now, let's just jump right in. Now we're going to use sum and difference formulas, so addition and subtraction, to find exact values. So look at number 1 here, cosine 75. So up until now, we know nothing about 75 degrees, right? Up until now, we would just hit our buttons on the calculator and get some weird decimal. Well, now we change. Now we start thinking about, are there any two angles that we know where if I add or subtract them, I get 75? And there are. It's, I would say, a 45 and a 30. So cosine 75 we could rewrite as cosine 30 plus 45 degrees. All right, and if I look up at my formulas, now I'm going to start using the terms alpha and beta. I can't just use theta anymore because now I've got more than one angle. So now I'm calling it alpha and beta. If you want to use A and B, that's fine. If you want to use X and Y, that's also fine. Okay, so now I see, all right, well, there's two angles I know that I could add to make 75. And since this is a cosine question and it's a sum formula, now my focus goes to this very first box. And I see that cosine alpha plus beta is the same as, I'm going to rewrite the formula here, cosine alpha cosine beta minus sine alpha sine beta. And since it's addition, 30 plus 45, it's commutative, so it doesn't matter if you had written the 45 first. All right, so cosine alpha would be cosine 30 degrees, which I can find here in just a minute. Cosine beta is cosine 45. Sine alpha is sine 30. Sine beta is sine 45. Okay, now, hopefully by now you're kind of getting used to all our 30, 60, 90s and everything, so I'm not going to draw them out a whole lot anymore. Cosine 30 should be root 3 over 2. Cosine 45 is root 2 over 2. Sine 30 is a half. Sine 45 is root 2 over 2. Okay, then if I simplify that a little bit, I get root 6 minus root 2 all over 4. Now, if you have a calculator in front of you and want to just check that, hit your mode button, make sure you're in degrees, hit cosine 75, and you should get some crazy decimal. Then enter root 6 minus root 4 divided by 4 separately, and hopefully you get that exact same decimal. All right, I'm also going to ask you to do some of these in radians. So you have to put kind of that logic, that number sense side on your brain. If you have something that says, like number 2, sine pi over 12, okay, think a minute. Okay, we don't know twelfths of pi's, but we do know sixth. We know pi over 6 is 30 degrees. Okay, so pi over 6 is 30 degrees. So that means pi over 12 must be 15 degrees. Okay, now if you didn't make that connection, you could always convert. It takes a little bit longer. You could take pi over 12, multiply it by 180 over pi, you'd still get 15 degrees. So now what I've got is I've got sine 15 degrees. And now we're trying to think, what two angles do I know that add or subtract to make 15 degrees? And I see 45 and 30. If you were thinking 60 and 45, that also works. But I'm going to go with 45 and 30. So I'm going to rewrite sine 15 as sine 45 degrees minus 30 degrees. All right, and there's my alpha minus beta. Okay, now I don't have my formulas on my screen, but just look. Sine alpha minus beta looks like this. Sine alpha, cosine beta, minus cosine alpha, sine beta. And for this particular problem, alpha is 45 and beta is 30. So I'll rewrite this with 45 and 30 now. Sine 30. Okay, same thing. Now we replace our numerical values. Sine 45 is root 2 over 2. Cosine 30 is root 3 over 2. Whoops, 3. Cosine 45, root 2 over 2. Sine 30, 1/2. I get root 6 minus root 2 this time, all over 4. Now let's do one with a little bit bigger angle, 165. Now, you can't do more than two angles. It's got to be two angles that you know that add or subtract to 165. So if you look at this one, So 2 angles only, and it might be a bigger angle. Okay, so think about this. You know 30, 60, 90, 45. That's what we know. And any multiple of that works. For instance, I know cosine 180, I know tan 180, I know 150s, 120s, anything that gives me a reference angle of 30 or 60 or 45. So I'm thinking that tan 165 can get rewritten as tan 120 plus 45. Okay, so then I'm looking at my tan formulas. Remember, the tan you don't have to memorize. It's going to go tan 120 plus tan 45. So this is, I'm going ahead and replacing the alphas and the betas with 45s and 120s, over 1 minus tan 120 times tan 45. Now, 45 is easy. You can kind of picture the 1 root 3. 120 degrees, you might want to think about it on the circle so that you make sure you've got the right positives and negatives. Okay, 120 is in the second quadrant, 60-degree reference angle, so it should go root 3, and then the x value should be -1, so careful with that, and then 2. So when I say tan 120, we're going to say negative root 3. Tan 45 is just 1, so that's kind of nice. 1 minus tan 120 is negative root 3. Tan 45 is 1. All right, let me take a peek. Simplify that up just a little bit. Okay, so I have this on the top. I have this on the bottom. Now we know in math we cannot leave that radical on the bottom. So now I'm going to come in with a conjugate and make sure I rationalize. Here's what it looks like now. All right, so then be careful with your foiling here. First, outer, inner, last. There's the top. Here's the bottom. Keep going with the algebra. All right, algebra, algebra, algebra. And then finally clean it up just one more time. So -2 plus root 3. All right, number 5, I'm going to do part A now, and then we'll leave part B for class, and we'll also leave number 6 for class. So we're only going to do 5A, and then we'll skip up to number 7. Okay, now let's consider our little all students take calculus business. I'm telling you that tan alpha is 5/12, so tan's positive, and cosine's negative. So now you have to think, where is alpha? All right, so tan's positive, cosine's negative. Hopefully you're seeing that my alpha triangle is in the third quadrant here. So there's my alpha. Okay, then let's put our numbers in. Tan would be opposite over adjacent, little Pythagorean, and then come back and don't forget your negatives. Okay, now my beta triangle, look over here. Sine beta is negative, cotangent beta is positive. So again, you can see this one, hopefully after you think about it a minute, also in the third quadrant. Here's my beta. Sine is opposite over hypotenuse. Come in with a negative. And go ahead and do Pythagorean or recognize the 30, 60, 90. All right, now the problem part A says sine alpha plus beta. Let's go ahead and expand the formula. Sine alpha cosine beta plus cosine alpha sine beta. Now I'm going to go back and forth between my alpha beta triangles. So sine alpha, if I look at the first triangle, would be -5/13. Cosine beta on the other guy would be -root 3 over 2. Plus cosine alpha, -12/13 times sine beta times -1/2. All right, a little bit of cleanup here. 5√3 plus 12 all over 26. All right, so we'll skip B for now, skip number 6 for now, and off to number 7 we go. Now we're talking about identities, so this is more like 7.3. We're trying to prove that the left side equals the right side. Now, the part that has the alpha plus beta or alpha minus beta, that's typically the side you want to start on. So if I look at number 7, I'm going to start with expanding cosine alpha minus beta. So I go cosine alpha cosine beta plus sine alpha sine beta. And it's all over sine alpha sine beta. Okay, now this section typically has only one trick, not like the last one where there are 5 tricks. The trick is, what can I divide the numerator and the denominator by to get the answer? Okay, well, if you look at this one, hopefully you see it's kind of nice. If I take cosine alpha cosine beta, so this first little bit, and I divide it by sine alpha sine beta. Can you see that I would get cotan alpha cotan beta? Okay, so cosine over sine is cotan. So that's how I get that one. Then if I take the second piece, sine alpha sine beta, divided by itself, then I get the 1 that I need. And then whatever I do the top, I have to do the bottom, so look what happens. So the bottom goes away completely, because sines over sines are just 1s. So it's a little messy to write it like this, but then I get, in one swoop after that, I get the answer. Cotan alpha, cotan beta, plus 1. Got it. Okay, so I'm going to do number 8 as well, and then we'll leave number 9 to do together in class. Okay, so again, the part with the alpha plus beta, we're going to expand. So on the left, cosine alpha cosine beta, minus sine alpha sine beta on the top, and then the exact thing on the bottom, except we're going to change to an addition between the two things. Okay, now, hopefully in one swoop, I'd be able to divide top and bottom by something to get the answer. Now, some students think it's hard to figure out what it should be, so I say pick the easiest thing on the right side. The easiest thing on the right side looks like a 1 to me. These 1s look pretty nice and easy. So then you think, how do I get cosine alpha cosine betas to become 1? What should I divide them by? And hopefully you're seeing the answer is itself, right? Cosine alpha cosine beta. Cosine alpha cosine beta. All right, so then if I take it piece by piece, those both give me 1s. Okay, so let's set up my answer here. Those are both 1s. And then the numerator had a subtraction, denominator is an addition. Now look, what would sine alpha sine beta, sine alpha sine beta divided by cosine alpha cosine beta give you? Sine over cosine is tan, so it should be tan alpha tan beta. Same thing on the bottom, tan alpha tan beta.